Morning, and thanks to everybody who is watching online. As Sandro kindly said, I'm Aarti Holla-Maini. I represent the Global Satellite Operators Association. And, you know, we address many topics that concern satellite operators in the association. Lately, in the last few years, 5G and now 6G is becoming more and more important. And within that field, of course, the question of direct access, direct connectivity to handsets is coming up more and more. It's a controversial subject. It's a bit like the Holy Grail. We are not really sure whether it actually exists or not. But if we look at how much innovation there has been in this sector in just the last couple of years, then we have to realize that anything is possible. So against that background, I would like you to welcome the experts that we have with us this morning. We have Mohamed Jaafari, 5G systems engineer and lead representative from Thales Alenia Space in 3GPP RAN 1. Welcome, Mohamed. We have Munira Jaffar. She's Director of Spectrum and Standards at EchoStar Corporation. She's also the chair of the GSOA Standards Working Group, so she does a very important role within the association as well. And we have Gino Masini, Principal Researcher with Ericsson, working on standardization. Gino is former 3GPP RAN 3 chairman, and he's worked with satellite in ESA research projects. And joining us online, we have Zheng Li. Zheng Li is a research engineer at Orange Labs Networks in France. She's a PhD in telecoms, including research on coverage extension in rural areas, with a special focus on NTN. So we're going to start today's panel with short presentations from each speaker, and then we're going to get into a lively discussion around some key questions, and I hope that you will also have questions from the floor. So if I can invite Mohamed to please come up and keep your presentations, please, to 10 minutes maximum each. Thank you.
Thanks, Aarti. Thank you, Aarti. Good morning, everyone. Actually, I have 14 slides and I have only 10 minutes. So I hope that the moderator will give me 2 or 3 minutes more. Okay, it's a pleasure to be with you today to share with you the latest 3GPP status, on the 3GPP standardization of non-terrestrial networks. This is the agenda. We will quickly go, recall the integration of non-terrestrial network in 5G. What is it? Why do we need it? Then we will have an overview about the standard, 3GPP NTN standards, the roadmap, and the content. This is what I would like really to share with you today. What is the content of release 17? What will be the content of release 18 and beyond? Then I have just one slide at the end to share with you our vision about satellite links in 6G. Regarding the integration, I think the question that we may ask ourselves, why do we need the satellite integration, in 5G and in 3GPP ecosystem? And why 3GPP, and what are the use cases, basically? I think this is the first day. Different speakers provided inputs on this question. So basically, the first use case is the coverage, to have this global coverage, to reduce the digital divide and to resolve the 0G issue. Because, as we know, 90% of the globe is yet to be connected. So from this point, basically, so this is NTN, 5G NTN offers, complementary role to terrestrial networks. Then the other use case is to use the 5G NTN in cases for which the terrestrial network alone is not enough, to combat. You can think, for example, about mobile on moving platforms, to drones and so on. So using combining the non-terrestrial network and terrestrial networks will be beneficial for service continuity and availability. The same device, the same standard device can be used for satellite comms, but also within the terrestrial network. The other use case, it was mentioned yesterday and this morning by some speakers, Jean-Pierre Chauffret from SAS yesterday, about multicast broadcast. I think it's very interesting, to leverage the satellite coverage, wide coverage, to use multicast broadcast as use case. And of course, through GPP, 5G, it's really the good technology, the best technology for that, to take benefit of 5G features, quality of service classes, network slicing, security. This is very interesting, as discussed this morning, for automotive and so on. I think security is very important dimension that should be taken into account. And of course, that's one thing here. Of course, I have been interworking with through GPP ecosystem is not something new. Since GSM, through GPP, the satellite was used, for the transport, for the backhauling. What is new today is really the integration in the RAN to provide direct connectivity to the smartphones, to the devices, and indirect access. Let me move. I will not go through more details here. Regarding the content, so through GPP release 17, basically, this is the first release that will be remembered as the first release in which the satellite links is integrated within through GPP. It's really the first release, specified release. And targeting direct connectivity in frequency range 1 or sub 7 gigahertz. We say sub 6 giga, but actually it's sub 7.125. Targeting, target terminals, handsets, including smartphones, okay? To provide wideband with few megabits per second using LEO satellite and using based on 5G new radio. The other use case, the other stream is about IoT end-to-end targeting IoT devices and in orbit basically. And based on 4G narrowband IoT and MTC. Then, this is release 17. Release 18, release 17, by the way, was completed actually in the through GPP in June. ISN 1 was frozen in June. Now we started in the through GPP to work on release 18, and for end-to-end, the target is to provide indirect connectivity in frequency beyond 10 gigahertz, Ka band, Ko band, and so on. And we target basically here this indirect connectivity. So the target terminals are VSAT and eSIMs. Okay. All right. Of course, using any orbits and to provide broadband services with 100 megabit per second. Then regarding the standards, so this is the roadmap. In the first day, the rancher, Wanshi, provided the whole roadmap of 5G, okay? The package, the content of release 18. What I would like to do here is to zoom and to go to focus on non-terrestrial networks. So basically, as I mentioned just before, release 17 is the first release in which we have specification to integrate non-terrestrial network in the 5G on a 3GPP ecosystem. Basically, release 17 introduced enhancement to adapt the content because the aim at that, is to reuse existing algorithms and the existing specification and to make some adaptation, okay? Then we have different enhancements were achieved in different areas, 5G system features to provide access, backhaul. In the RAN, we have enhancement, based on a transparent payload architecture. Release 18 will continue. The architecture will be still based on transparent payloads, and it will introduce other enhancement. I will have 2 slides or 3 slides to provide a little bit more details. Release 19, the discussion in 3GPP on Release 19 has just started in SI1 to define the requirement, but we expect that Release 19 will introduce regenerative payloads and more enhancement for non-terrestrial network. Release, for 6G, we will have one slide at the end. Okay, now, what is exactly in Release 17? As it was mentioned, I remember in the first day that we would Release 17 basically will, as I mentioned just before, we will use existing specification and we make some adaptation to address the major issues that we have with satellite links, like long propagation delays, of course, so large Doppler shift. And we have also a big issue with moving cells. Okay, so this is a big issue. We have also a problem with large beams. So we will have differential timing within the same cell. So there are a lot of challenges, and all the specification achieved specified in Release 17 have taken into account such constraint. So as I mentioned before, the focus in Release 17 is transparent architecture. We support moving cells and Earth fixed cells. So with beam steering, you may fix the beam, the footprint on the Earth, okay? Or you can use this Earth moving cells. Both scenarios are supported. The spectrum, the target spectrum is below 7 gigahertz, S-band and L-band, and we are targeting user equipment, handheld, including smartphones, which are equipped with GNSS. Then, of course, we forgot this, but end-to-end based on you and you with implicit support of the hubs. The hubs also is part of this non-terrestrial networks. Then, briefly, this is exactly the content of Release 17, and you will get the slide afterward. I will not really have more time to go through details and maybe during the questions and answers. So in different areas, we have introduced mini enhancement. So in run one, we have timing relationships enhancement, the synchronization, time and frequency synchronization, to cope with the large round trip time. Okay, and the Doppler, so we have some pre-compensation at user equipment to perform such synchronization. We have enhancement on the HARC. The hybrid IRQ can be disabled, or we can the number of HARC processes can be up to 32. Yes, and so on. In run 2, so this is the access layer. We have also many enhancements in the user plane, the control plane. We extended the timers and so on to cope with the satellite link constraint. Both enhancement in user plane and control plane, system information broadcast with the SIB19, new SIB. Then we have in run 3, we have different enhancements that are listed here, but Gino will provide maybe more enhancement, more details about run 3 aspects. In run 4, so this is related to RF, RS, radio measurement performance requirement, and so on. So there are also many enhancement regarding the time compensation, GNSS accuracy requirement, and so on. We have also coexistence between TN and NTN, and Munira will provide more details about that. Then finally, we have system level also. We have different enhancements here. To cope with considering new class, quality of service class 4G and so on. Unfortunately, I will not have more time here, but of course, during the questions and answers, I will be happy to discuss all those aspects. Okay, then for just briefly, in nutshell, Release 18, what is the content and what we need to remember, at least from run point of view. So we have the most important point is that Release 18 will consider deployment above 10 gigahertz. So this is something interesting. We will support also VSAT user equipment. This is something also interesting. Then there are other enhancements, about user network verified geolocation to support regulatory services. There are enhancements to the coverage to enhance uplink coverage. This is also interesting. And there are also some enhancements related to the mobility between terrestrial network, non-terrestrial network. This is very important for, based on the discussion this morning, for automotive and so on. It's also very interesting to have such seamless mobility between both networks. For the IoT, we have also other enhancements, disabling the HARC feedback, improved GNSS operation, mobility enhancement to support this discontinuous coverage, and so on. Then finally, I have 2 slides, and I will stop here. Sorry for regarding the 6G. I think we have one slide that we can summarize actually our vision. Basically, before what we are doing today with release, starting from release 17, before we have only interworking between satellite standards and terrestrial networks. Okay, so we have the design was optimized independently for each networks. The release from release 17 onward, what we are doing today is this integration, 5G. Yes, so satellite integration with 5G ecosystem. So here, as I mentioned before, the idea is to reuse existing specification and to make some adaptations. So the design was optimized for terrestrial network, okay, component, and we will. The idea is to have minimum impact to support integration of satellite for coverage and availability extension. Now, the future 6G. The idea is we do not need anymore to distinguish between TN and end-to-end. So basically, from day one, we need to have a unified design and single network which take into account terrestrial constraint and non-terrestrial networks constraint. So, as example, the waveform from the beginning should take into account this constraint, and we do not need anymore to have. The design should be optimized, taking into account characteristics for both terrestrial and satellite components. Then the last slide is the takeaways that we need to keep in mind. Is that with release 17 today, this integration of satellite with mobile system is now possible, with starting from release 17 onwards. This is actually the result of joint effort between stakeholders for both satellite and both mobile and satellite industry, for both who both find the benefits, and we are very happy as Thales and Thales Alenia space to be one of the companies who pushed from the beginning to such integration. So basically, satellite added value for 3GPP is to have this global service continuity and resiliency, as I mentioned before. And for and the 3GPP added value for satellite is to have this access to access a unified and large ecosystem and standard. It was mentioned by different speakers from the beginning, actually, and this is of course will be beneficial, to drive down the cost and through economy of scale. And also, as mentioned this morning, this end-to-end standards is supported by telecommunication user groups, public safety, automotive, and so on. Good examples is the nice presentation this morning. I think that's paving the way for new business opportunity, and this is the last slide from my side. Thank you very much.
Thank you very much, Mohamed, for giving us your perspective there. I'd now like to invite Munira to the podium. Munira, you and EchoStar have been really driving this work within 3GPP. Please give us the satellite operator perspective. We've heard from Thales as a manufacturer. I'd love to hear your perspective on where this is going to go with respect to direct connectivity. Thanks.
Thank you very much, Aarti, for the introduction. So if I can get the slide up there. Okay. Also, to continue on Mohamed's briefing earlier on the progress of NTN, I would like to just start with high level on EchoStar. Can you move the slide? Oh, I see, sorry. Okay, so just high level on EchoStar. EchoStar supplies the connectivity that millions of consumers, enterprise, government agencies, and communities depend on. It's public here. It's a multi-billion-dollar public company and with premier global provider of satellite communication solutions. So last year, UN revenue about 2 billion. We mostly operate GEO satellite right now, 10 GEO fleet of in KU, KA, and S-band satellites. Today we are operating S-band satellite that covers Europe. And EchoStar has a series of S-band rights, assets, and also licenses. And also, we hold global ITU and GSOA S-band rights. Our flagship service in the US and Latin America, HughesNet, it connects millions of people across the Americas. We provide broadband services, direct to home, direct to business, enterprise, and so on. And yeah, in the very near future, hopefully in a few months, Hughes is gonna launch Jupiter 3. That is a high throughput satellite which will double more than the capacity of the Jupiter 2-3. So just high level on the EchoStar Corporation. So on NTN standard in 3GPP release 17, so as a premier global satellite service provider, we have been very active in pursuing satellite to be part of 3GPP 5G ecosystems. Huge, together with EchoStar, we've been key players in driving these activities. Of course, with a joint effort with other stakeholders, including mobile and also satellite operators. And it's well supported by the verticals such as public safety, transport, automotive, and many more. So as a result of all this effort, I would say starting release 17, when we started really serious and pushing this in 3GPP and get into release 17. So it is really a very important breakthrough in 3GPP release 17 to have satellites, or we call it NTN, non-terrestrial network, to be specified in 3GPP release 17. That is when we complete the normative phase. So today, NTN NR and also NTN IoT is included in the 3GPP technical specification. The two main tracks, of course, number one is the NTN NR, which is a new radio. So this is a specification, it's a set specification for satellite 5G direct access to handheld devices in FR1 frequency range, which many of you know here, it's below 7 gigahertz. And equally important is NTN IoT. So this is a set of specification for satellite direct low data rate services, EMTC and also NB-IoT in the 3GPP specification. Today, for NTN IoT, we do not have the RF core part yet because it's right now being worked on in RAN 4, and that should be completed by the end of this year. So, so the takeaway here is today satellite operating in the MSS band will now be able to deploy 3GPP standards to provide service directly to handheld that are also used in terrestrial and cellular system. So very important here, I think Mohamed covered quite a bit earlier, what are the frequency bands that we will be able to implement here. So the two bands that have been specified is, first is the S-band. You can see the uplink frequency range here. That's UE transmits 1980 megahertz to 2010 megahertz. And on the downlink is 2170 megahertz to 22 megahertz. So that's 30 megahertz up and 30 megahertz down. Of course, it is FDD duplex mode. And the second band is L-band. You can see the frequency range there, uplink and downlink. So both these bands has been defined in 3GPP as, I guess I don't have the chart, the right band here, it's different. It is N256 for S-band and N255. So a lot of people get confused because it's 3-digit, they think it's a millimeter wave. No, it is the starting frequency labeling for an NTN band. So start 256, 255. If there is additional band, then you go down. So 254, 253, and so on. So it kind of a split between NTN and NTN band and also the millimeter wave. So as a result of this, also all the critical NTN features, such as those characteristics and all the satellite impairment has been adapted. So the specification has been modified to make sure that all the satellite characteristics and impairments are adapted in the 3GPP specification, such as Doppler and delays and so on. But also very important from the RF and performance requirement side of the FR1, 2 new specification has been specified for NTN and R. So the first one is definitely the UE equipment itself. So this is new. So the new specification that define the UE, the NR user equipment that allow NTN access as far as the RF and radio performance. And the second important specification is, of course, the base station, which in the 3GPP specification, we call it satellite access network, which consists of GNB and the satellite payload, the feeder links, all included in the components, as part of components of the satellite access network. All right, so what does it mean with all of these, efforts and the specification in 3GPP? So this allows seamless integration between NTN, NTN, and I gave you a high-level snapshot there. So with this definition, satellite and terrestrial operation now share common technology, and in turn, a common user equipment, which we expect is the handheld device, smartphone, and so on. And also with the seamless integration, it enhances global service continuity and reachability, resiliency in unserved and underserved areas. So there are areas that are waiting for this to happen, that you use one device. You can go outside the urban areas, go to the rural, and you can go into the forests and the ocean and so on. And this also will improve service reliability through connectivity to various access technology, in this case, satellite and terrestrial. It is important for critical communication, such as emergency or national disasters. And it also enables satellite access to a large ecosystem. So as a result, it may drive down the cost through the economies of scale because of common, infrastructure maybe, and also common user equipment between NTN and NTN. And lastly, I hope this is exciting. It opened new market opportunities for both cellular and also the satellite stakeholder as well. So with that, I end my presentation. Thank you.
Thank you, Munira, for that. Thanks for your mobile phone as well. It's okay, I'll give it to you in a second. I wanted to hand over to Gino Masini from Ericsson. Gino, GSOA is a very active member of 3GPP. Ericsson's an important player amongst the vendors. Tell us, are we there yet? Please.
With pleasure.
Thank you, Aarti, Madam Moderator, and thank you, ladies and gentlemen. So, I'm the only person coming from the terrestrial networks world in a room chock full of satellite specialists. I guess I'll have to play the heretic here. But the distinguished speakers before me, Mohamed and Munira, have made an excellent job of summarizing the hows and the whats of NTN and 3GPP, and we also remember the good presentations by the 3GPP chairman at the beginning of this conference. So I can concentrate on the why. So are we there yet? Why are we doing this, first of all? So why 3GPP and why now? So these are some of the reasons. Well, 3GPP standards, we're talking an open and global standard, which means interoperability, it means future-proof solutions and a wider ecosystem. If some of you today still has a 3GPP sanctioned, obviously, a UMTS phone from several years ago in their drawer, assuming they can still charge the battery, they'll put in a SIM, and if there's a 3G network out there, chances are it will still work. It will still provide you the connectivity and the features for which it was designed and specified, maybe 15 or 20 years back. Same thing if you have an LTE phone from the early release 8 or release 9 days. 4G networks are here, and it will still happily cooperate with the network. That's because this is an intrinsic capability of 3GPP specifications. They are a lingua franca of telecoms worldwide. Try doing that with your PC. Try doing that with any file you might have opened on your PC 20 years ago. Do that and then tell me how it goes. So then, this offers for NTN a technology commonality with cellular. So again, economies of scale and cost reduction. So this is a good global technical standard for you. Why now? Well, 5G is a flexible platform. 5G supports a wide range of services and applications. You have mentioned IoT, you have mentioned MTC, the public safety ecosystem, and many other things. So it's the natural environment for NTN to plug into. And of course, we have the usual technology advancements. So the satellite communications employs the most advanced technologies, and this also enables us and you to think stuff that until, well, the day before yesterday was the stuff of Star Wars, inter-satellite links with optics. I mean, how cool is that, right? And one additional enabler, these are all very real critical success factors for your industry, I take. The reduced development cycle and cost of satellite manufacturing and launch. So all of these things are coming together right now. And they have been coming together now for some years. So you have seen these timelines. This, I try to not to repeat for the nth time what you have already seen. But this is just to highlight what should be very dear to your hearts, and I guess to everybody who works in 3GPP as well. So it's the timeline with the milestones that everybody should remember for NTN. Those things in red boxes. So SI stands for study item and WI stands for work item. So in 3GPP jargon, anytime you introduce a feature into the actual specifications, it's because of a work item. Study items result in technical reports, which are nice to read, give you a feeling for what was discussed and for what may be possible in future specifications, but they don't change the specs. Work items do. So these three milestones: service requirements in 2018 in SA1, then the famous now release 17 work item, integration of satellite in 5G by SA2, and if you remember the presentation from 2 days ago, SA1 and SA2 work in the systems architecture technical steering group. SA1 deals with very high-level requirements. SA2 is responsible for the overall architecture. And then these things trickle down to, for example, the RAN working groups and the CT working groups. I happened to serve as the 3GPP RAN 3 chairman. RAN 3 is within the TSG RAN. It's the group that handles radio access network architecture, protocols, and interfaces. And of course, we were involved in the work item in Release 17, solutions for NTN, for NR-NTN, as well as for the NB-IoT LTE-M variant. So these four things enable NTN to be part of the 3GPP ecosystem. And of course, we have grand plans moving forward, from what I heard from everybody in this room. So so-called 5G Advanced, release 18 and 19, and going on to 6G and our brilliant future. So we have come a long way. One thing that I have seen in my previous role as chairman is that the whole NTN community has come to 3GPP with a very constructive and positive attitude. This doesn't always happen. So in this case, I guess what I have seen from your colleagues that came to our groups is that you have given the impression that you're here for the long run, you're here to build something, and you're here to actually become part of the 3GPP ecosystem. So as far as I'm concerned, I'm happy to continue being part of 3GPP and to discussing NTN matters with you guys. So this thing will probably move forward. Once again, from what I see from the satellite industry, you guys tend to create value in the long run. You launch something today that is supposed to still work in 15 years' time. That ties a lot into the 3GPP mindset. I gave you the examples of compatibility that we have moving forwards and backwards. This is actually an integral part of how we build our protocols, both the air interface protocols and the protocols used in network interfaces. Backwards and forwards compatibility through some tricks that we use with ASN1 and how we specify things, optionality and criticality. I don't need to go into the nitty-gritty details, but if you're curious, you're welcome to ask me questions anytime. So once again, there's a lot of commonality of intent. Having said that, and then I will leave my role as today's heretic. Are we there yet? Well, two things. First of all, the NTN ecosystem, from what I hear, is still very much vertically integrated. So you guys are building your own ground stations. You are building, deploying, and operating a certain constellation of satellites. So that, to us, is part of the you might call it the NG-RAN node, or the G node B in 5G terms. And by the way, G node B is not a pun on my name. It's this urban legend that some people tend to propagate. No, yes, I was the chairman, but they didn't do it for that reason. Exactly. So the two interfaces with which this very special NTN G node B talks to the outside world or talk to other parts of the ecosystem are the UU interface towards terminals, and that's specified by 3GPP, and at least the NG interface with which it talks to the core network, the AMF. That's also specified by 3GPP. UU is specified with all its protocols by TSG RAN Working Group 2, so RAN 2, and NG is specified by RAN 3. So at least those two enablers are in place already today. Release 17, and we're enhancing those for Release 18. Release 18, we're adding a few bits and pieces to the mobility enhancements, making sure that mobility is more and more seamless between terrestrial and non-terrestrial networks. Once again, we're not defining kludges and hacks and options and stuff that only apply to a subset. We're defining stuff that is actually self-consistent and that works across the whole ecosystem. Of course, each terminal or network manufacturer is free to implement some or only parts of those, but the lingua franca of standards tells you that in order to have a certain functionality, in order to offer certain services to your end users, you should do things the way it's specified to ensure that everything works together. Now, another big topic is spectrum. Spectrum is an enabler. 3GPP does not define the bands and the usage. To do that, you have to go to ITU, you have to go to WRC. So we take what is defined today and we work with those bands. And the working group in RAN that works with bands and radio requirements and all of that is RAN 4. So RAN 4 also does radio resource management requirements, RF, coexistence. But once again, we take the bands defined somewhere else. And this is where it gets political. And this is where I'm actually quite happy to work in 3GPP. So having said that, the answer is, are we there yet? Not yet, but we're certainly getting there. So I guess the challenge is, I suppose, now for the NTN industry, the satellite industry, to continue doing their homework. 3GPP, I think, has done a lot of work, and I think we can be confident that we have done our part. Thank you very much.
Gino, thank you. That was very interesting indeed. Thanks very much. I'd like to invite, I think we have Zheng Li online. Hi, Zheng Li, good to see you.
Hi.
I know you're working on different proof of concept tests for direct connectivity to handhelds, so I'm really glad that you can be with us on this panel. Can I invite you to share your perspective from Orange on this topic? Thanks a lot.
Hello everyone, and apologies from my side first that I couldn't make the trip to the grass. So I would like to, but luckily I have this Teams link to discuss with you our opinions on this direct connectivity. Could you confirm that you can hear me correctly and see the slide correctly?
Yes, we can. Thank you.
Okay. So we have already seen 3 very interesting presentations from Mohamed, Munira, and Gino. So now I would like to give you some ideas from the perspective from the operator side on this direct connectivity. I think most of you have already seen this figure that was included in the GSMA report. Also, there are some figures, the numbers to present why it's important for operators to look at NTN and connectivity, because there are still 6% of the world population are not covered by the mobile broadband. 3.9 billion people do not have home or mobile internet access. And 93% of the world's unconnected population live in low and middle income countries. So, and in these places, coverage extension with classical solutions is both economic and technical issues. For example, in developed countries, the average revenue per user could be very low, and the end user, the devices are not always available. Plus, there are additional technical constraints to reach the very remote places, and also lack of physical infrastructures. Therefore, NTN is a very promising solution to provide ubiquitous coverage to users in deep rural areas to complement the mobile network operators' terrestrial network. This is why NTN is quite important from operators' perspective. And I think you have already seen this a lot of times during the meetings. So just to remind, for NTN, we have GEO, MEO, and LEO. Both all these 3 different altitude satellites are important for operators. And also, we will not forget the high altitude platform stations and the drone. I will pass this slide quickly, as the past 3 presentations all talk about the NTN studies in 3GPP. But just to mention that for Orange, the main concern, because there are a lot of different use cases included in 3GPP and for NTN connectivity. But for Orange, the main concern is digital divide, which means the coverage extension for population living out of the network. This is the first motivation for Orange. But we do not forget the revenues of existing clients in these areas that may provide new revenues. And also, the topic of this panel is the direct access. And the direct access for Orange, there are also, of course, we know there are direct access to smartphones and to IoT devices. But here in my presentation, I would like to talk more about the direct access for standard smartphone for voice and data services. The main goal is the objective is to seamless integration of LEO constellations with terrestrial infrastructures. I'm talking about LEO here because the LEO constellations are gaining a lot more and more attention now for the reduced cost, the larger data rate, lower latency. We also noticed that I think most of you, of course, you are aware that there are several ongoing initiatives targeting the direct access to standard smartphone, either with proprietary solutions or 3GPP compliant solutions. And however, the current LEO constellations that already can provide the services on smartphones are mostly proprietary. So for operators, we focus more on the challenges that could appear with that we have to overcome first before we really provide services to direct access to standard smartphone. Here I would like to talk about the 4 key challenges. The first one is regulation. Actually, in the presentation of Munira, Gino, and Mohamed, they all talk about spectrum. So you can already feel that the spectrum is a very important topic for NTN access. We know that for spectrum, the central question is, do we use dedicated the MS band, which already we said S band or L band for satellite access, or do we allow the reuse of terrestrial network, the terrestrial MS band for satellite use? On one hand, MS band, they may have they have smaller bandwidth compared to the terrestrial bands. And also you have to have agreements with satellite incumbents. But on the other hand, to reuse the terrestrial network bands, first, it is very controversial. You have to have acceptance. You have to require acceptance from ITU ecosystem, and also you have to negotiate and have permission from the local regulators of each country. And also for operator, this is a very important point to look at, because if the terrestrial band is reused for satellite access, we have to be very cautious with these frequencies, and we have to be sure that the possible interference from the satellite on the terrestrial network can be totally managed. This is for the spectrum part, and for regulation, of course, there are some also other challenges. For example, the orbit saturation, the space impact, something like this, and of course, social acceptance. And the next challenge is related to the device and chipset. For us, Orange is following very carefully the studies on NTN at 3GPP level, especially for the device part, because the 5G NR access by satellite is a key lever for is a key lever, and more generally, end user devices, which should today are proprietary. But if you want really to let everyone to access have the direct access to satellite, you very low or no impact on the devices should be achieved. And also, as I said, for Orange, we would like to. The main concern is for the coverage extension for in rural areas. For example, in Africa, we operate. We have operations in 18 countries. For example, in Africa, we have to make sure that the low cost smartphone which can be used for NTN access, is accessible in every countries. And also the third the third challenge is about the technology design. For example, interference management, we have to be sure co-channel interference or adjacent band interference can be managed. And also the system design, how do we, for example, the functional breakdown and the architecture, and also the word architecture, how do we deploy the mission segment all over the world. And finally, we also pay attention to the energy impact, which would be bring by the NTN access. For example, what is the comparison with terrestrial infrastructure, the CO2 emission, the consumption of the energy, something like this. These are the main challenges that from Orange perspective. Okay, that's all for my presentation. Thank you.
Okay, thank you very much, Zheng Li. I'm going to stay here now with the panelists. We're going to get into a discussion. And we have heard a lot of interesting aspects. I do hope that you will also have questions from the floor. I'm going to start with some of my own. The first one is going to be to Mohamed. Mohamed, you told us everything that's going on in 3GPP. You went through in detail some of the different technical considerations. I would like to hear about Thales. You have been a key driver behind this work. Why? As a satellite vendor, how do you see this change impacting your business directly?
Thanks a lot for this question. Indeed, yes, we are active in 3GPP specifications because we believe that having standard is very beneficial, for satellite communications, because as you know, before basically we have proprietary solutions, for almost each constellation. You have to define proprietary technology, dedicated user equipment, and so on. And it's clear that this is not, for the cost reduction and take benefit of economy of scale. We need standard for that. So, and why 3GPP? Because we believe that 3GPP standard 5G, it's really something very flexible, as mentioned by Gino. We would like to take benefit of the different features of 5G features related to quality of service handling, related to introducing network slicing, security. It's a major point that should be considered. That's.
Okay, thank you. And Gino, can I jump straight to you, building on from the Thales point? Because obviously direct access is going to require modifications in the base stations, but the standards are they've only just been finalized. 5G has already started rolling out. So how do you see that happening? How are you going to work with the satellite primes to make that all happen? Aren't we too late?
No, you're not too late. You're actually right at the right time, I would say. So, first of all, I don't need to repeat it again, but I guess I will. Release 17 is there. That's the first start. Then changes happen incrementally. And normally, each change does not throw out the window everything that was done before it. So, Release 18 base stations are going to include everything and anything that was specified up to Release 17, provided that the manufacturer thinks it makes sense, meaning a certain feature in Release 18 will not throw any incompatibilities in the customer's or in the operator's way. Of course, the issue is, will operators go for this upgrade? Will manufacturers go for this upgrade? And that's, I guess, up to the market. It's up to the everybody in this room and also in 3GPP to, as I said, do their homework. So it's a bit of a challenge, as always. 3GPP only specifies a certain functionality. Whether that functionality will become a success or not, it's not written in any of our specs. It will depend on the market uptake. But if the market uptake is there, the functionality is going to be there, and we do as we always do. We work with the ecosystem because we believe that a stronger ecosystem benefits everybody, I would guess. I guess one of the things I like to tell my students is an example from Pompeii, the city of Pompeii in southern Italy. Streets of Pompeii, you know, the roads there, they have stones, and they built a sort of tracks in their ways. That's what I call an early example of global technical standard, because everywhere in the Roman Empire, carts had to have the same width so that they were able to circulate in all roads. So this is something that we try to do with different means, but with the same spirit, even today in 3GPP.
So in other words, you try to anticipate and plan ahead. Obviously, this is expensive technology. Does that mean that companies like Ericsson don't necessarily wait for the specs to be finalized and published in the final release, but that you do it anyway? Is there a push from you to the operators in that sense?
So the push is not one way. It's actually everybody pushing into the standard from different directions. That's how it works. So the specifications, at least when you talk about serious players, I'm not saying Ericsson is a serious player and everybody else isn't, but definitely the people that actively contribute in 3GPP are serious about these things. Yeah. So they come with their requirements, operators, infrastructure vendors, chips and manufacturers, handheld vendors, and so on. They come very early. And the definition of a content of a release happens very, very early in the process. So development inside companies happens at the same time and in parallel as the standard is being developed. And since everybody is working together in the same places, it actually goes in the same direction. So very seldom it happens that the standard goes one way and my technology goes in another. Well, by construction, it doesn't happen because I'm actually having feedback in both directions, in and out of the standard. So in this way, once the standard is out, everybody is pretty much aligned. And in terms of timeline, well, when the release is out, usually you start at least, this is what happens in terrestrial networks. I have no idea whether the same timeline can be replicated in the satellite industry. But in terrestrial world, standard is out today. You can see the features rolled out to customers within a time frame of roughly 3 years. So this is what can reasonably happen for any feature in Release 17 for those concerning terrestrial networks. Release 17 out now, so 2025, you will see this stuff rolled out in the market.
Right. So you used serious players here. And now we know how heavy is the work that you do in 3GPP. We know it requires some serious time commitment and some serious engineering. Yet, I thought this was going to be a question just for Mohamed and Munira, but in fact, I think it's for all of you, including you, Zheng Li. We have just seen what Starlink has put out there, SpaceX. You have been working so long, for so many years on this, between Thales and EchoStar. You've done the lion's share of the work on the NTN standard 5G NR. And then SpaceX comes along and says, hey, by the end of 2023, you might be seeing direct connectivity, right, with their latest announcement. What does that mean? Where does that leave all of these standards? Do we not really need them then? Where does that leave us? Who wants to take that one first? Go on, Gino.
I can take that. First of all, I'm okay. I told you, I'm the heretic. I'm happy to play the bad guy or, throw stuff at me. Go ahead. No problem. So I have seen this in many occasions in my career in 3GPP from different industries. So, of course, you have the early players, you have the early adopters, the fast movers. That's fine. The thing is, sooner or later, if the ecosystem develops, everything becomes pretty much organic, because what it tells the world when you're a fast mover, the first guy adopting this for a certain network, for a certain system, is that you have done your homework. So you know exactly how to do your stuff, you know what you're doing, and well, chances are you have done all the effort in-house to develop some functionality which, if it works, well, pretty much it works in the same way as a 3GPP does, except you didn't benefit from the coordination and from the communication to other players. So you have the first mover advantage, you also have the first mover disadvantage. You had to reinvent everything from scratch. So this, I'm afraid, is something which I see a lot, I have to say this, in the satellite community. You guys have the Formula One mindset. Let's tweak and fine-tune and do everything in-house in our own workshop until everything works perfectly. In my world, we don't race in Formula One, we build Toyotas. So this thing has to work to the right specification. This doesn't have to be the most beautiful piece of engineering in this world. This have to work up to specifications and have to be replicated in high volumes, because the key is high volumes, but the high volumes are enabled by global standard, and global standard are enabled by serious work, as we said.
If I can respond, follow up to Gino from Ericsson. From our perspective, I think whatever the announcement is, we look at it as something very exciting. That shows, satellite is, very important. It's becoming more and more, I would say, sexy. So, but I fully agree with Gino. I mean, you have to be sure that what you're going to be deploying is going to be a global ecosystem, and that's really the goal and the effort to be part of the 5G ecosystems, and working side by side with the mobile, the terrestrial operators, as well as all the other stakeholders, like I mentioned earlier, the public safety folks, all those things that sees this is coming. So I think it's a really true, genuine effort that eventually that one day, I would say sooner or later, if not really 17, but there's a lot of enhancements that we're doing today to make sure that it is a realistic standard that can be deployed, that eventually, the goal is to have seamless integration with terrestrial, that eventually the what service that we provide is something that's really useful and credible. Thank you.
Mohamed?
I would like just to add that we need also to check what there is exactly inside, with such constellations, because to provide, this global connectivity, basically, if they do not choose exactly what was specified in 3GPP, it means that a lot of work will be done at network side, like compensation, the time in advance, Doppler, and so on and so on. And basically, they are creating like a proprietary solution, okay? And they will be also limited to specific vendor, so they will not take benefit of this. To use another vendor and so on. And we think that sooner or later they will need to join, this 3GPP standard.
Mm-hmm. Okay, Zheng Li, can I ask you to weigh in? What do you think about this? What's the impact of the standardization work? Is it really required?
From my side, of course, it's very exciting news because, now we are working on the satellite access, but there are a lot of public, they are not aware of the future of NTN connection. For example, when I talk with my friends that I'm working on the future direct access from satellite, they are surprised to know there will be this possibility. So I think this news is exciting. It can track more attention from the public to let them know the potential of NTN access. But also in terms of the news itself, I think it's already, as they said, we need to be sure that the system is properly constructed and to make everything is working. And especially for operators, we need to prove that the feasibility of the constellation, and this is the most important thing for operators. Yeah.
Thank you. Another question, Gino, bouncing off something that you said that we have this Formula One mindset, right? We tweak and change and so on. But you're right. We are essentially a proprietary industry. Here we are talking about standards, scaling. I mean, standards are central to economies of scale, to scaling up, to addressing a mass market. That's what direct access is meant to all be about. Yet even when we, excuse me, look at the NGSO plans, each one is different. Each one is different. How's that going to work? Is there going to be one winner? And is it going to be the one who's following the standards? Or is there room for all? How's that going to work? Open for all. Who wants to start? Munira, come on.
Yeah. Okay, as far as we're concerned, as you know, I think it's very clear that EchoStar and Hughes together, we have been working on this from the very, very beginning, fighting so hard within 3GPP to even get in the room. People are saying, satellite, you go away, go and define your standard somewhere else. So we were very persistent. Eventually, we were approved for release 16, the study, and then release 17, which is the normative phase. So it is very exciting. So as far as we are concerned today, we are exploring options. I mean, now that the standard is beginning to take shape, we're exploring options on how we are going to leverage the S-band asset that we have today. We are evaluating the opportunities, how we can leverage this into a new long-term growth, avenue of growth of opportunities, including the commercialization of the S-band itself. And we view and we hope that the new 5G phones, the smartphones, will include this S-band. So that's as much as I can comment on. Thank you.
Mm-hmm. Gino, you want to come in on this?
Yes, of course. Again, drawing from my own experience, a very personal experience. My dad lived in San Francisco. Some 25 years ago, he was still alive. He was telling me, cellular phones are no good because I take my cellular phone in San Francisco, I travel to Nevada, it stops working because California and Nevada had different technical standards. So, of course, global economies of scale kick in, and then at some point, you had a harmonization. It took a while. But then once harmonization is there, you don't go back. It will take, I don't know how many years. I'm not a futurist here. We have a futurist in the room. It might be interesting to have such skills. I don't, I'm afraid. So I don't do that sort of predictions now. But eventually, you will never have, I mean, think about it. You will have an end user that has a fully functional 5G phone with 3GPP technology. How is that going to work if you ask that guy, okay, but you want to have global communications technology with the Starlink of the moment? Can I use my phone? Yes, no, maybe, sometimes. You might want to have a dual mode phone. You remember, in the old days, you would have dual mode phones for Americans that travel to Europe, and those phones were twice as bulky as regular phones because there were two built into one. So this is also something that will have to come into play. So it's convenience for the end user. Mobile telecoms has been very good at this. Other technologies only learned that thing the hard way. Anybody remember the analog color TV standards until the 1970s? NTSC, PAL, SECAM, or deliberately incompatible? Of course, there can be standards. There can be WiMAX versus 3GPP, and guess who won in the end? Simply because 3GPP provided a good story, and it was not a story, it was actually a reality, to migrate and to seamlessly integrate from 2G and 3G into 4G. WiMAX didn't have such a good path. So we know what happened. We talked about integration, another integration story. CDMA 2000 and LTE. In LTE base stations, S1AP, which is the protocol that the base stations talk to each other, has a functionality for seamless handover between CDMA 2000 and LTE. A small effort on 3GPP part meant something big for CDMA 2000 users whenever such a function was deployed. Mm-hmm. Even on geopolitical terms, China had its own homegrown 3G system, TD-SCDMA. But in the end, I think they made the right decision when it was time to move to 4G. China was part of the 4G ecosystem. So these things eventually, at least if we draw from past experiences, these things eventually do happen. How long will it take? Nobody knows, but I'm confident that it will actually happen.
I'm glad to hear that. Mohamed, do you want to come in? I mean, as a manufacturer who is providing satellites to multiple different operators, is there any kind of push that you can offer to adopt some kind of standardization on satellites going forward?
Yes, for sure. As I mentioned before, yes, working on such TGP standard will be really beneficial, as satellite prime. And as also mentioned by Gino, having such global standard will be really something that is really very important, yes, for all actors, yes.
Let me rephrase. I mean, manufacturers are typically in the hands of the operators who specify, these are our requirements, this is what we want our satellites to do. And each one is competing with the next, right? So it's not necessarily saying we want something which is going to work with all systems, open standards. That's not how an operator typically comes to a satellite vendor, right? So is there any room for satellite vendors to push back a little and say, look, think about the direction of travel of the ecosystem as a whole and get with the program,
Yes. It's of course, yes. When we have such standard, it's really important, to have the same. Basically, for each program and for each operators and so on, you need to do everything from the design of the constellation, even the specific user equipment for such program and so on. Now, when we have such global standard, for sure, it will be very interesting. Yeah.
Okay, thank you. Gino, sure.
Yes, just 1 second. Interesting, the relationship between vendor and operator. We do that all the time. Actually, it's one of the things you have to watch out for when you're part of the 3GPP ecosystem. Ericsson cannot just go out to any operator and say, we have this shiny new feature and we think it will benefit your users, great coverage, you will increase your throughput data rate by so much %. The first thing that the operator will say is, great, I want to be able to see it in the standard. So let's bring it to 3GPP together. Reason? Well, because in the end, it will mean more choice for the operator. It will not be an Ericsson proprietary feature anymore.
Right.
Then they have more choice. They say, okay, I want this feature. Who can provide this to me for the better value for money? Is it Ericsson? Is it Nokia? Is it Huawei? Is it CTE?
Excellent.
So this is actually probably the double-edged sword, one of many, of being in 3GPP.
Okay. I know we have questions from the audience. I'll take them in just a second. But Zheng Li, I'd like to bring you back in. Gino was just mentioning about the interaction between the operators and the vendors. And indeed, GSOA, since we became market representation partner, despite the obstacles put by Terrestrial, I empathize with you completely, Munira. We entered into an MOU with NGMN, the Next Generation Mobile Network Operators Alliance. And indeed, the first thing that they said to us was NGMN was set up because we wanted to have operator-driven standards and not have vendors just, telling us what we need. So, interesting point that you make. But when do the operators expect for NTN to come into play in the market? Zheng Li, can you share your thoughts on that?
In terms of the timing coming to the market, I think, there are different initiatives that targeting, for example, 2025 or even 2024. But from our perspective, we need to prove, as I said again, we need to prove the technical feasibilities first before that we predict the time for NTN coming to market. But basically, I believe that it will not be very far from now. Yeah.
Thank you. And Munira, maybe I can come back to you. When can we expect to see satellite companies like EchoStar delivering this kind of service?
Yeah, I think I have indicated quite, clearly earlier that we're still, evaluating the opportunities. We also want to make sure that the standard is a little bit more matured. So we'll actually, start to explore this, side by side with with some other partners, on the satellite side as well as on the UE side. So, like Zheng Li mentioned, it is still quite far away. We feel that the manufacturers or the vendors that are involved, there are so many different components there. The chipset, especially. Companies like Qualcomm, MediaTek, and so on. So they have to be prepared as well. The SAN manufacturers, Thales, Ericsson, and so on. I'm sorry, I mentioned the name, just giving an example. And lastly, the UE vendors. Those are also important to make sure that these vendors are well prepared. They're very confident that the specification have addressed all the, at least the critical specification that needs to be there for them to start. So everything will evolve together, and that's when operators will feel confident that this is something that we can start planning. I'm sure other operators are doing the same thing, and if there is anything still missing, anything, we go back to release 18 or release 19 to it, and more that will benefit eventually the ecosystem and definitely the end users.
Thank you. Gino, you wanted to come in?
I pretty much agree with what was said. Thank you.
Excellent.
Not
Sorry,
this time.
I thought you raised your hand. You wanted to come
it's
in.
fine.
Okay. I'm going to take some of the questions which I see have come in online. One from Maria Crego Blanco. Munira, it's for you. Munira, on your seamless integration slide, you showed a scheme with CN Satellite and CN Terrestrial as different entities. The idea is to have completely new core networks for satellite, or anyway combine terrestrial and satellite once. What's the answer to that?
Yeah, the diagram is just a high-level snapshot of if we were to interoperate with between satellite operators. I cannot see the question. Between satellite operators and mobile network operators, so eventually the user equipment itself will gain from the interoperability or any kind of arrangement that happen between satellite and mobile network. But at the same time, as we evolve, I think there will be at some point of time that even satellite and also terrestrial system can share a common core network. It depends on in this scenario. I mean, probably initially interoperability will take place between arrangement between NTN and NTN, but somewhere down the road, it can all be in one system. Thanks.
Thank you. Gino.
Yes, the way the standards are built, the core network can be the same, and indeed is probably eventually going to be the same for terrestrial and satellite. The way normally an operator works is they have their own core network, which takes care of the user subscription and the appropriate nodes and so on, and then through the same open interfaces, the NG interface namely, you can connect to an NTN G node B and a terrestrial G node B. So it's fully supported. Yet again, something that 3GPP has had for many releases is the possibility to share parts of the network. So I guess operators can also consider network sharing of various parts of the network. MOCN, GWCN, MORAN at various levels. I invite you to look these up. I don't wish to, to go into the details. There are at least 3 different flavors of sharing the RAN, the core network, or both. And this is something that has been with us for many releases and is fully applicable also to NTN.
Okay.
I would like just to add that natively, starting from release 15, basically the 5G core is the common core network, and single core network can be used to connect through GPP based access and non-through GPP based access. It can be also terrestrial based access or non-terrestrial based access. Yes. So the same core network can be used basically.
Thanks. Okay, so some of the questions, I want to take them and morph them into something else, but we will answer them. So, of course, we're here discussing high-tech stuff, but at the end of the day, it's the user that is at the center of all of this. It's about connecting people who are not connected. It's about, and it's not just about increasing the number of subscribers and giving connectivity to those who have nothing. It's also about those who do have connectivity, who want to stay connected when they're going from one place to another. So let's think on the spectrum side for a second, because we hear, I mean, when we listen to what SpaceX wants to do, that's essentially taking the mobile service, so PCS spectrum, and integrating it into a mobile satellite service. You can't just, well, technically, practically, maybe you can just do that. But from a regulatory and spectrum point of view, that requires important changes of the ITU radio regulations, which only happens once every 4 years at the WRC. So, and some of our questions have come in, indeed, about the standards, well, some of the services, the direct services which have already been announced, it's only really about SMS and things like that. It's not really about the type of services we're talking about when we talk about direct access, right? So how do you see that playing out? Do you think we're going to have players who are non-compliant and go ahead anyway, against not deliberately in that sense, but simply because the pace of innovation is so much faster than the pace of evolution of regulation, right? It requires consensus, it requires global dialogue, that takes time. So what are your thoughts on this issue? Who wants to start? Go on, Gino.
I think the very first part of your statement is key. So we are talking about the end user here. So if the end user is required to buy yet another more expensive or flashy gizmo, it better be good and it better work. Otherwise, it's just one more box to be ticked. It's just one more obstacle. The reason why at the beginning, you know, the famous pagers were so successful, they were small. Doctors and lawyers could wear them on their belt, and they just worked. And that's, I guess, one of the reasons why at the beginning you start small with this sort of services. They don't stress your network capacity so much. You can build humongous cells for just a few kilobits per second, you know, emergency communications like the Apple iPhone 14 and so on. So it really has to come down to something which is usable for the end user. Do I require my customers to switch terminal? Do I require before the end term? Of course, in 2 years' time, we will be switching phones, and then there's the next 3GPP release, which includes NTN technology. But do I want something right now? So, okay, I have to scramble one more charger, one more thing to worry about the battery charging, and so on. So, is it really practical for the user?
You didn't comment on the regulatory side, though.
As I said, I'm very happy I'm in 3GPP. I don't engage in spectrum wars. I try to be more constructive.
Okay.
Yeah, if I can comment something on more about what we have done in 3GPP. We brought MSS band because that's regulated for satellite to operate mobile satellite services. I mean, there's so many different aspects of standardization that we have to do in 3GPP. We have to at least bring something that's already been authorized by ITU, authorized by FCC, and authorized by the regulator in different countries. This is to ensure that, you know, if we're talking about global ecosystem, that not just, you know, users in one country can use it, but make sure that all the countries are being checked. So by having something that's already regulated by ITU, so I think that's, you know, you're following the regulation, you're ensuring that it's going to be something that can be used all over the world. So to your question on what's, you know, the Starlink and T-Mobile's doing. To be honest, I'm not sure because, you know, if you know, it's clearly that if the spectrum is allocated for terrestrial use, you cannot use it for satellite. If the spectrum is allocated for satellite, you cannot use it for terrestrial, with the exception that for S-band that we are authorized in Europe, we do have authorization from European Communication Commission to be able to deploy complementary ground component, which is actually a typical terrestrial base station, but with the condition that satellite is still the primary service, and there are other conditions that says that if the satellite fail within 180 days or something, then your ground component is no longer valid. So it's meant to have opportunities to augment capacity. So, but it's subject to regulation. So we typically adhere to regulation very strictly. Thanks.
Thank you. Okay, there's another question. I'm taking the questions which are online. If there's any in the room, please raise your hand. There's an interesting question which has just come in, and I think it actually is looking beyond direct access, maybe even to 6G. We talk about the relationship between satellite and terrestrial going from interworking to integration to unification, right? So the question that's come in is, will it happen in the future that a mobile operator contracts a satellite manufacturer to produce a satellite to become integrated in the NTN-TN network? That could be, that's where you would expect unification to really come from. I don't know. Can anybody foresee that happening? I guess that a satellite operator would also be involved. You would hope that that would be a partnership of terrestrial and satellite operators that together define and procure some kind of requirements. Munira, do you want to take that?
Yeah, I think that's definitely possible. I think more and more we're thinking about being more creative with the way that we are going to evolve with this standardization. I see in the future that, this is based on some of the discussion we've had with mobile operators in the joint project between ISWAR and GMN, where Orange was also involved. So in that paper, in that study, it was a position paper that was put together by a couple of satellite operators, including EchoStar, Inmarsat, and Intelsat, together with Orange and Vodafone, and I can't remember one more operator. Eventually, the idea is to have mobile network operators who have licenses in areas that they cannot serve, such as Africa, some parts of the, all those areas, because it's not cost effective for operators to serve this license. Eventually, the license might be taken away from the regulators, right? So there is a scenario whereby, using the MNO licenses in those countries that they engage satellite operators to provide the service. We may not have to have the authorization but it can be some kind of arrangement whereby, we sell this coverage and capacity to the mobile network operators. Thanks.
Thank you. Zheng Li, you have to come in on this question, please. Would love to hear your perspective.
Yes, I was going to add some comments from my side. Yes, as I said, the spectrum, for example, is there's possibility that we use the terrestrial spectrum for satellite use, but we have to be very careful to evaluate the feasibility, to evaluate the interference to the terrestrial network, because for Orange, at least for the moment, our main goal is to use NTN to complement the regions where we cannot have access. In the regions that we already have terrestrial network, we prefer to stay on the terrestrial network. And also, as Munira just commented that, for example, in African countries, maybe the satellite can use the terrestrial band to provide services. And I think maybe some of you have already seen the news that Orange has already signed an MOU with IST Space Mobile to test their Blue Walker Street satellites this year in one of our African countries. This is exactly the case that Munira just mentioned. So I think this is a very good example for this unified 6G future, NTN-TN future.
Thank you. We're out of time, so just one last question for everybody. When we look at all of the innovation that's happened and all of all the work that you guys are continuing to do, we think that even when something looks technically impossible, you guys are so good that you will find a solution, you will find a way. It's just a question of time and probably money funding for all the research, right? But one of the questions that came in is it really feasible and affordable given the hard reality of the laws of physics? So let's close with that question. You're all top-notch engineers. Tell us what you think.
Okay, I would take this question. I think the question is about the throughput, and that all recent announcements actually are about direct access with limited, it's 2G-like or 3G-like services. I think, first of all, we need to start somewhere. So this is just the beginning. Then when discussing actually the provided services, this will depend on a lot of factors. One of the factors is the spectrum, of course, depending on the spectrum that you use, depending on the techniques that you use. And ITUR are working today, these days, about defining the requirement for IMT 2020 by satellite. And one of the requirements about is to provide direct connectivity to handheld with 1 megabit per second in the downlink and 100 kilobit per second in the uplink. This is experienced data rate. So this requirement is already there, and basically we need to satisfy such requirement. For VSAT and user equipment with directional antenna, we will even have higher throughput, like 50 megabit per second in the downlink and 20 megabit per second in the uplink. Then first of all, and also, I would like just to add the last point is that in release 18, we are working on many enhancements, to improve the coverage and thereby to improve the throughput provided to user equipment. Yeah.
Thank you. Munira, Gino, you want to come in on this question of, is it really feasible given the laws of physics?
I think that's what this specification is all about. What we have done from the very beginning was to analyze those impairments, the distance between the UE and different constellation, LEO, MEO, and GEO as well. Those has been analyzed, and also the fact of the LEO constellation move. So there's a bit of Doppler effects and delay. That was the very first thing that we actually started in 3GPP, is to analyze the physical layer, which is the concerns of the law of physics. So until we realized that is actually doable, there's a lot of areas in the specification that could be modified to factor in those impairments. I don't understand the details, some of the K offset, the timing advance, maybe Stefano can describe better. There's a lot of parameters that we modified in RAN 1 to make sure that the physical layer can be adapted in the 3GPP specification. Then only we move on to, okay, what are we targeting here? What type of UE, class 1, class 2, class 3, and so on. What can be applicable? But we also have to be mindful of the expectation. We're not going to be able to provide the same level of service as a 5G terrestrial. That is clearly understood from the very beginning. Was the minimum that we can deliver using smartphone from LEO satellite for pedestrian, for people using either phone. And as you all know, we are targeting mostly outdoors, because right now we don't think it's possible to provide service even from LEO satellite using S-band or L-band to users who are indoors. So those are things that has been analyzed, definitely taking into consideration the law of physics before we even move on into defining the bands and all those different features.
Thanks.
Yes.
Okay, Gino, last word for you, focusing on the user and the affordability part. Of course, being great engineers, anything, you can make it come true, but will it be affordable as well?
Exactly. Well, I don't know if I'm a great engineer, but definitely laws of physics govern my whole being, pretty much my whole work. And specifications are not sales brochures. They're not slideware. So what you see in the specification is not what might happen on a good day when the wind blows the right direction. what you see there is the consensus in 3GPP at the time the standard came out for what can be achieved given all the right boundary conditions. So it's very much realistic. And actually, for every figure and for every number in, let's say, a RAN 1 specification or RAN 4, there's a counterpart. A very seldom mentioned working group is 3GPP RAN 5. RAN 5 works on conformance testing. So anything that claims to be conformant to a 3GPP specification has to undergo testing according to RAN 5 specifications. And there's a one-to-one correspondence to those. So you want to build a Release 17 NTN-capable phone, there is a RAN 5 specification that tells you how you should test, what you should test, and the exact parameters to test. Laws of physics are everywhere.
Excellent. Thank you. Well, I hope you enjoyed that session. I found it extremely interesting. Please join me in thanking our speakers, Zheng Li, who joined us remotely, Gino, Mohamed, and Munira. Thank you very much, and thanks for everybody who watched online. It's time for lunch, and today lunch is going to be in the foyer and not in the dining room. Thank you.
Okay.